At the end of the day, working with indices in Python becomes intuitive, and that's why the term index is used by professionals quite loosely. Still, in our previous video, we showed that the Pandas series index represents a very solid data structure. Sometimes this structure can be explicit, other times implicit. In this lecture, we will clarify the distinction between the two types. In addition, we will introduce the technical terms label-based indexing and position-based indexing. So, let this be our starting point. Consider the index of the Series A object. It is composed of consecutive whole numbers starting from 0 and ending with a number equal to the number of values in our series minus 1. Since we have stored 5 values in this object, the index runs from 0 to 4. By referring to the index attribute, we see that this isn't just an index, but a range index. This means that the values of the index are the same as the numbers of a sequence generated by the range function, with a start value of 0, a stop value equal to the number of elements stored in the series, and a step value of 1. It is crucial to understand this type of indexing. I realize that this could be a challenge for you, as it seems a bit tricky. So, what you must remember is that the numbers from this index, which have been displayed on the left, refer to a position within the ordered sequence, displayed on the right. That's why, when the index of our series is a range index object, we observe position-based indexing. You can also call it zero-based indexing. There is another feature of this type of indexing that might seem strange at first. Take the number 20, for instance. It is in the second position of our series. However, we also say that it has an index position of 1. By the same token, the number 40 is in the fourth position, but it has an index position of 3. To avoid any confusion between the two phrases, we should try to predetermine which figure we would use and stick with it. I guess that's why most professionals will refer to the index position of a value rather than to its actual position in the given sequence. To wrap up what we've said so far about zero-based indexing, we can also execute the type function to confirm that we are dealing with a range index object. Then, we can paste series A.index as an argument of the built-in list function to prove that the sequence of index values is composed of the integers 0, 1, 2, 3, and 4. All right, we can continue our work with another familiar object. I'm referring to the prices per category series. Let's execute the selected cell to obtain it. With or without the help of the type function, we can refer to its index attribute to see this is a standard index object, so to speak. An indication that the index values of our series are most probably non-numeric. Normally, we will opt for non-numeric indices if we want to use names that will logically correspond to the data values contained in our series. Such names are called labels, and this is the reason why the type of indexing we have in prices per category is referred to as label-based indexing. Great! So, in terms of programming in Python, we can mainly distinguish two groups, label-based and position-based. When you think of it from an analytical perspective, though, you must be aware that we can also have explicit and implicit indexing. In prices per category, we used a dictionary to create the series and its keys became index labels. This means that we have explicitly specified our index, hence the phrase explicit indexing. However, there may be situations in which you won't be working with labels. This doesn't mean that you can keep coding without an index, though. If the user doesn't specify an index, Pandas will immediately attach the default zero-based indexing to their object. This way, they can refer to the object's values via their positions. That's why, in Series A, we observe implicit indexing. Remember that this will always be the default numeric index. As we scroll up, you can see that we have not been specific about the index of Series A while creating it, and yet we have implicit indexing. I hope what we've seen so far in this video has made the conceptual difference between explicit and implicit indexing in Python much clearer. In the next lecture, we will reinforce what you've learned here by applying indexing to different scenarios. Thanks for watching.